Hello, welcome back. Today I'm going to cover an introduction to machine learning for professions in the built environment. Some of you may wonder, what is machine learning and how is it applied to buildings? Machine learning is an application of AI or artificial intelligence that provides the system the ability to learn automatically and improve from experience by feeding data and information in the form of observations and real-world interactions. Machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. According to the book Prediction Machines, published by A.J. Agarwal, Joshua Gans, and Avi Goldfarb, machine learning consists of prediction, decision-making, tools, strategy, and society. In this video, we will be applying machine learning in the context of an architect. Let's dive into this story. For the first section, we have prediction. Prediction is a process of filling in missing information by taking data and using it to generate predictions or information that you don't have. Architects can input floor plan data sets into generative design software that's driven by AI to create building footprints according to the requirements by a client, such as shape of the floor plan perimeter, splitting of room functions, and furnishing of the space. The generative design also has the ability to adapt to changing constraints. Moving on to the next section of decision making. Making a decision requires applying judgment to a prediction and then acting on it. However, there are limitations as most AI machines and equipment do not tolerate uncertainty and are designed to operate in a rigid environment. Therefore, humans are still required to make judgments. For example, after the floor plans are generated by the generative design software, Phil is required to present the generated floor plans to a client for decision-making on which design best suits the project's requirements. Finally, let's look at the last three categories of tools, strategy, and society. The actual implementation of AI is through the development of tools. These workflows consist of tasks, which are collections of decisions. AI may shift the emphasis of specific skills required for a particular job and lead to the reconstruction of jobs with certain tasks added and others removed. In the context of architecture, people will be able to spend more time on decision making rather than drawing up floor plans. Also, prediction and judgment are complementary. When the use of prediction increases, the value of judgment rises. The Prediction Machines book also talks about the risks of AI. Data management is very important for machine learning, as models are only as good as the data that you feed them. Firstly, it will cause quality risks if the data being fed into the AI is too sparse. Second is there's a risk of destructive behavior learned by AI if the feedback provided by the occupants are being manipulated. Finally, predictions with AI can suffer from insufficient data that could lead to discrimination. To prevent these risks, data science have to ensure that they have the right data sets. They must be mindful of the sources and kinds of data that they are using to train the algorithms. Lastly, to prevent bias, AI needs to have an abundance of diversity of data to build robust models. In conclusion, machine learning has the opportunity to impact every profession in the built environment. The best way to stay on top of new developments in the way machines learn is to continue to learn yourself. This video concludes our exploration of data science for various people within the building industry. Just like them, I hope you keep on learning.